educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the extraction, properties, and uses of sodium. In our last lesson, we learned about refining and alloying. We learned that metals are refined to remove additional impurities. We discussed the three methods of purification, including distillation, electrolysis, and zone refining. We also learned that alloying, which is performed by melting metals together, is a method of adding a range of new characteristics to a host of metals. This might include added strength, lightness, or affordability. In today's lesson, we are going to learn about how sodium is manufactured using the Downs cell. We are also going to demonstrate some of the chemical properties of sodium and describe some of its uses. Let us begin. Sodium is a soft, silvery white metal that is highly reactive. This metal is not found free in nature, but rather it exists in the form of various compounds. Sodium is a strong reducing agent, and unlike many other metals, it cannot be reduced by carbon. Sodium is obtained by the electrolysis of a molten mixture of about 40% sodium chloride and 60% calcium chloride. This is carried out in a Downs cell. Students, this is what a Downs cell looks like. Calcium chloride is added to lower the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. Liquid sodium metal is formed at the cathode. Since this metal is less dense than molten sodium chloride, it floats to the surface and is collected. Chlorine gas forms at the anode and is collected at the top of the Downs cell. Students, on a piece of notebook paper, please write down what substance is formed at the cathode and what substance is formed at the anode in a Downs cell. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to name the substance that is formed at the cathode and the substance that is formed at the anode of a Downs cell? If you said that liquid sodium metal is formed at the cathode and chlorine gas is formed at the anode, then you are correct. Let us do another activity. Explain how sodium metal is obtained from a Downs cell.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. The liquid sodium metal that forms at the cathode is less dense than the sodium chloride that is also inside the Downs cell. As a result, the liquid sodium metal floats to the surface of the cell. It is then collected. In this video, a man has created a homemade version of a Downs cell, and he is producing sodium. You should not try this at home, though, students, because it can be quite dangerous. When he takes the lid off, you can see the silvery white molten sodium that has floated to the surface. Let us continue our lesson by learning about some of the chemical properties of sodium. When sodium reacts with water, it liberates hydrogen and forms a sodium hydroxide solution. The reaction looks like this. When sodium reacts with air, it tarnishes to form sodium peroxide and sodium oxide. The reaction looks like this. Of the products formed, sodium peroxide is the major product and sodium oxide is the minor product. Sodium also reacts with hydrogen to form sodium hydride and with halogens such as fluorine, chlorine, bromine, and iodine to form sodium halides. Those two reactions look like this, respectively. Students, let us do one last activity for this lesson. We have already seen the balanced chemical equations for sodium when it reacts with the halogen fluorine. Please write the balanced chemical equations for the reaction of sodium with chlorine, with bromine, and with iodine.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. I am sure that your chemical equations are all balanced and correct. Let us go through them together so you can check your answers. When sodium reacts with chlorine, it forms the product sodium chloride. When sodium reacts with bromine, the product sodium bromide is formed. When sodium reacts with iodine, the product sodium iodide is formed. We have discussed how sodium is manufactured and also some of the chemical properties of sodium. Let us finish our lesson by learning about some of the uses of sodium. The largest use of sodium is to make a sodium-lead alloy. This alloy is needed to make tetraethyl lead and tetramethyl lead. These compounds are used as anti-knock additives in petrol. Knocking occurs in spark ignition internal combustion engines. This happens when pockets of air-fuel mixture explode outside of the envelope of the normal combustion front. Sodium also reduces titanium tetrachloride and zinc chloride to their metals. Liquid sodium metal is also used as a coolant in nuclear reactors and to make sodium peroxide, sodium hydride, and for streetlights. In today's lesson, we learned about sodium. We learned that this silvery white reactive metal is manufactured using the Downs cell. It forms at the cathode of the cell and floats to the surface because of its density. We also learned about some of the chemical properties and uses of sodium. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.